And with that, we'll go ahead and get started with our next presentation, which is going to be from Okan Bulut. And let me just give you a quick rundown of his experience. So welcome, Okan. Okan teaches courses on psychometrics, educational measurement, and statistical modeling. His research areas include educational data mining, big data modeling, computerized and digital assessments, psychoeducational assessments, and statistical programming. His research has been published in Educational and Psychological Measurement, the Review of Educational Research, and other peer-reviewed journals. So, Okan, great to see you again, and thanks for joining us today. I should mention that Okan was part of our a session that we had last month, kind of a lead-up podcast to the Beyond Multiple Choice, and so having heard that, that is available on our website. I'm looking forward to hearing even more about your work. So thanks for joining us.
All right. So Brian, can you hear me? Can we just run a quick sound check?
Yep, you're good.
Is it good? Perfect.
You're good.
Great. Thank you so much, and it's great to be here. So thank you for inviting me to this wonderful event. So I think it has been a very nice experience to hear about all those different products, testing experiences, assessment experiences, about especially like digital assessments, something that I'm personally interested in my research. So today my research, or this is kind of my extension of my research, but I will be talking mostly about overcoming human error or kind of bias using AI-powered assessment. So for folks out there who want to download a copy of my slides, I just put the link in the bottom left corner just in case. So the slides, a PDF version, will be available. All right, so this is the picture that we used to see when we just think about assessments, right? Scantron sheets, bubble sheets, where you would take the paper and pencil test, and you would just basically just answer a bunch of questions and just write them down, or maybe just select one of the response options, typically multiple choice, and just choose the answer that you picked. So, and finally that Scantron sheet goes to a testing center, gets scanned, and then you get your final score. But nowadays, when we just think about the assessments, this is what we are just imagining. So computers, or in general, like digital assessments, tablets, or other kind of digital platforms that allow us to administer different kinds of assessments. So more authentic assessments, a little bit more flexible. I will just mention that in my next slide. But this is kind of like the future of the assessment. Now with the COVID, we know that we have all just transitioned to digital assessments. So I think it will be for the next couple of years, maybe decades, we will keep seeing this, and the Scantron sheet that you are just seeing on the left-hand side will disappear pretty soon. So why do we like digital assessments? Why do we like computer-based assessments, tablets, game-based assessments, and things like that? So this kind of assessments are kind of helpful because they allow us to incorporate those technology-enhanced items that include audio, video, interactive elements, experiments, and things like that. They also allow us to just have some additional test administration features, such as scrambling the order of items and response positions if you are using multiple choice, and a couple of other additional features that we can easily embed into the assessment system that we wouldn't normally have in a paper and pencil setting. We can also have this flexible test scheduling. Since we are not printing out any assessments, obviously we can have people log in anytime that works for them, and they can just take the exam in their free time. Also, we have this adaptive testing opportunity with computer-based testing or digital assessments, where the test can get more difficult or easier. So it basically tailors itself based on the students or examinees' ability level. So it becomes harder and harder, or easier and easier, depending on how accurately we are responding to the item. So it creates this personalized assessment experience. And finally, this is kind of like the point of my presentation today. The digital assessments allow us to have this objective and quick scoring. Since we use, let's say, an answer key, so in a multiple choice testing setting, so we can easily just get the scores right after each person just finishes or completes the assessment. So when it comes to digital assessments, obviously, just like in every single assessment, we have a bunch of options. So the main option is, the first option that comes to mind is multiple choice items or selected response items more generally. multiple choice, true, false, maybe matching items and things like that, where students or examiners would be given a series of response options and they would just select the right answer out of those. In return, so like the opposite side of that coin, so is constructed response items. In that case, constructed response items such as short answer items or essay items require students to type their answers by using their knowledge, reasoning skills, and critical thinking abilities. So when answering these abilities, when answering these items, sorry, so the students basically construct their responses without seeing any response options. So it is a little bit more authentic. It is a little bit more realistic in that case because they can express their responses by using their own language rather than picking up one of the response options that they were given. But obviously there's this clash between this response of these item types, right? So should we select selected response because they are easy, or should we select constructed response items, which may or may not be suitable for our assessments? So in our case, I just want to say that the constructed response items are relatively better compared to multiple choice items just because so they are much easier to develop. So you don't have to worry about finding distractors or incorrect response options for your items. So as you may know, so multiple choice items are great, but when it comes to just creating high quality items, they are so hard to create. So meaning that whenever you have some poor distractors, the distractors that are so easy to eliminate, so people already pick up the right answer directly. So no matter how good your question is, so at the end of the day, so people can find the right answer so easily, so then your assessment is kind of ruined. But compared to that side, creating or developing constructed response items is easier because we don't have to worry about those issues. So using constructed response items, we can also measure more complex skills such as comparing, contrasting, drawing conclusions, synthesizing information from different sources and things like that. And also, unlike multiple choice items or selected response items, we can assign partial credit to our constructed response item, since the response could be fully accurate, it could be partially accurate, it may not be accurate at all. So depending on the accuracy, we can assign some credit, no credit, or full credit at the end. And finally, I just want to emphasize this feature that, so compared to multiple choice or selected response items, again, constructed response items are less prone to cheating because it is so hard to just literally share your responses with anybody else in that moment. You cannot copy or just memorize the response options in that case because you are not given any response options in this type of items. But in return, so we have also some disadvantages. So the first of those disadvantages is the inefficiency in general in scoring and also in testing time. So this type of items take a lot of time to score, and also in the testing time, we need more time for students to sit down and then type their responses. It's not like multiple choice. Maybe we are giving roughly 1 or 2 minutes per item. In this case, this type of items require more time so that students can think about their answers, type it, finalize it, and submit it at the end. And also another disadvantage would be subjective human scoring and in return bias. So because we know that no matter how much training they receive, human raters could still be subjective in their scoring, in their marking. That could just lead to some bias issues. And that's what I will be talking about in the rest of my presentation. So we know that in the human scoring process, we give the raters some kind of training, the rater training, which about the scoring rubric, which allows them to understand how to score those items accurately and consistently. And this is kind of important because this type of training allows us to reduce the impact of different sources of bias and inconsistency. And after this type of training, the raters are presumed to follow the rubric accurately and consistently whenever they start marking those items. However, it is really possible that some raters may really get tired during the marking process and start maybe paying less attention to the scoring process, maybe missing certain details. That's one thing. And the other thing is also that some answers may really align with the rater's belief system, or maybe student could just add some off-topic elements that could impress the rater. So in that case, the rater would basically find the answer really tempting to overlook all those correct details or correct parts of the answer. And in that case, they will just assign some kind of mark or credit to that item based on those irrelevant elements of the item. So what happens is that this brings a lot of subjectivity and finally also bias or scoring error into this type of items. And whenever this type of issue really happens, we know that we will have a lot of inconsistency, a lot of error in our assessments, which is not necessarily good. So all day long, we've been just talking about artificial intelligence, emerging technologies, and other things. So can we really use AI or artificial intelligence to help us mark or automatically mark those constructed response items or written responses in that case? So before I dive into that, I just want to give you a definition of artificial intelligence. So basically, AI is kind of having a computer do something that we assume that only entities having like human-like intelligence could do. So basically, our goal is to create some kind of like an intelligence, artificial intelligence system that could mimic the human behavior. In this case, they are human raters, and they can just mark these assignments in the way that humans can just do. So in this type of scenario, we are using a sub-branch of artificial intelligence, which is called natural language processing, or shortly NLP. So NLP is dealing with the interaction between computers and humans using the natural language that we are all using. So NLP allows us to transform the language or different elements of human language into a format that computers can understand and process. So actually, NLP or natural language processing is not something that we are. It's not a brand new experience to all of us actually. So as you are using your phones, so the autocorrection feature in your smartphones, so that those phones, they use NLP in that case to autocorrect your sentences. Or when you use your Gmail or another email, so the spam filter is actually using the NLP in the background to identify which emails could be spams and which emails are true emails, the real emails. So, and the other things such as like Amazon Alexa and Siri, Google Assistant, and things like that, even chatbots. So they are running some natural language processing engine in the background to process your speech or your writing or your other like linguistic input, so that it transforms it into a format that computer can understand and reply back to you. So a couple of months ago, I had a short article about how AI can really bring fairness to assessments in the context of educational testing, basically. So that was published in the Taurus AI publication. So I just want to share the link. So that's kind of like the background of my talk today, because in my article in this magazine, so I just mentioned that AI can be used, but in the meantime, are we really ready for it? So is it good or is it bad? So can we really just start using it right away? So I will just show you a cycle of how NLP really works for creating an automated scoring engine that allows us to automatically score those students' responses without basically any kind of human input. So there's still some kind of human input, obviously, but I will just mention the distinction between those processes now. So first of all, we just have the students just write an exam. So it can be either a digital exam where they just type their responses digitally. That's the best case scenario. Or it could be a written exam, so then they can type their responses, so we can scan them through, so we can still digitize the written responses on a paper and pencil assessment. The second step of the process is to find some human raters. And just like I said, we still rely on human raters in this process. Those human raters will come up, so they will just take the responses, they will use the scoring rubric, and we typically need more than one rater in this case, because we know that one rater could be biased, so we need two raters or more raters in most of the time, so they can independently score all those items together, like on the test, maybe an essay, maybe a short answer item. So we can combine those and we can just see if they're consistent. So because their consistency is basically the essence of the automated scoring system that we will build later on. So once we make sure that those raters are consistently marking the items or grading the items independently, so now we know that we have a reliable baseline or gold standard, so we can move on. So the next process is, the next step of this process is typically to combine those student responses in the digital environment plus with the human scores that were assigned by the raters. So now we know each response and the corresponding score that was assigned by a human rater. So now it's time to just combine that data. So, and by basically using natural language processing models, we can start extracting some linguistic features. So this process is not necessarily like the same process as human raters really score this type of item. So what happens is that, so humans literally just follow a rubric and they just match the responses to a rubric and they just assign 0, 0, 1, 2, 3 points, things like that. But in this case, the computers or machines do not necessarily do that. So they are looking for the humans' response behaviors or scoring behaviors, and they are just trying to mimic that behavior in the scoring process. What happens is that it looks for some patterns in the system. So what kind of words or phrases just got the highest scores, or what kind of sentences were receiving full credit versus partial credit versus no credit at all. So this type of process could be manually done. So you can still specify some things that you want the computer to pay attention to, or it could be fully data driven, meaning that then the computer program can pick up all those features for you and extract them as much as possible, and you can start training your model. And speaking of the model, so we typically use neural networks or especially deep learning models in this type of process. So what happens is that now the text that we just got from the students' responses, it was converted into a numerical format. So our deep learning models will process that numerical data and try to understand or try to generate a scoring model at the end. So basically, once we build a scoring model or scoring engine, so now we can take a brand new essay that computer has not seen yet and just use it for scoring that essay, just like a human rater would do. So in this case, it is just like I said, it is just like a human scoring process. And by the time we just finish up building our scoring engine, it is ready to be used along with a human rater probably. So to mark as many items as possible and as efficiently as possible. So, and also I just want to mention that it is important to understand how that system really works. So because we still need to just check how things are really going with the scoring engine, just to make sure that we are still aligning our scoring mechanism with human raters. So it is important to check the accuracy every now and then. And basically the checking mechanism is pretty much like seeing how consistent marks are given by a computer with marks assigned by a human rater. So we just correlate them, or we just check the accuracy or match or alignment between those. And the more they are aligned, the better, obviously. So in the last 7 or 8 years, the Hewlett Foundation has been sponsoring a lot of competitions around this. So I just wanted to use their open access or publicly available data set to showcase how this scoring engine really works. So in one of those competitions, so they created an assessment that consisted of 10 short answer items. So the items focused on typically science, biology, English language arts, and things like that. And it was designed for grade 10 students. So in total, the number of participants or students was around 2,200. So lots of students, obviously, which is also a good thing in this case. So, and they had each student response rated by 2 human raters, just to see if the raters would consistently mark them. And that was the case. And each rater, basically human rater, used a rubric to assign 0, 1, 2, or 3 points to each of those items or responses. So let me show you an example item. So this is one of the items, in that case, is one of those 10 items in the competition. It's a science item designed for grade 10 students. So they are given some information about a science, a fictional science experiment. So students are supposed to read that information, all the steps, and they are just interpreting the table at the bottom. And finally, the question says, after reading the group's procedure, describe what additional information you would need in order to replicate the experiment. So make sure to include at least 3 pieces of information. So meaning that the students are supposed to write at least 3 pieces of information that would help them replicate the same experiment in the future. So the length of the responses were around like 50 words all the way to maybe like 200 words because some students had longer responses, some students had shorter responses. So in that case, once we just created a scoring engine around that, following the steps that I explained earlier. So this is the accuracy that I just got based on one item. So basically, accuracy refers to the alignment or how many times or what is the percentage or proportion of the cases where we see a match between a computer and a human rater. And for just one item, we were able to reach 87% accuracy. So 87% of the time, so the computer literally assigns the same mark as a human rater, basically. But when we consider all 10 items in this competition, the accuracy went up all the way to 95%, which is amazing. So because even humans cannot agree on their ratings or their scores that high. So basically what happens is that this type of assessment system or a scoring engine ignores all kind of off-topic elements, and it goes through every single response, and it does it pretty quickly as well. So at the end of the day, you get all of your scores back with high accuracy. And of course, the secret is that your responses should be as diverse as possible so that the computer program can understand what is a bad or poor response, what is a moderate response, and what is a high quality response. So in that case, the accuracy of the system really depends on how representative our items are on the test. So a very final thing that I just want to say is that, so this kind of systems are sometimes criticized severely because people think that we will bring AI to replace humans. It is not the case. So I just want to emphasize that the goal of automated scoring or AI-based scoring is not to replace human scoring at all. It is actually the other way around. It is just to improve how, it is just to understand how humans really score the items, because this is how we design the scoring engine. So that in that case, if you just better understand how humans really score the items or constructed response items, we can also improve both human scoring and also machine scoring or automated scoring in that case, which allows us to bring more validity evidence for our assessments in a long run. So again, it's not a threat. It is some kind of like a helper for us in that case. That's how we just need to just see this and just benefit from this kind of systems, hopefully as much as possible in the next couple of years, and just to increase the efficiency and to eliminate any kind of scoring bias, subjectivity, or systematic bias in the assessments or scoring of this type of assessments. And that was the end of my presentation, Brian. So I'll be happy to take some questions. I hope that we have some extra time.
Great, Okan, appreciate it. Great run through of some of the issues. I'm going to go ahead and launch the poll actually, so we can get folks to chime in on their perspective in terms of if they can see AI and assessments becoming ubiquitous or still being challenged, or maybe too many challenges to ever really gain traction. I want to reflect one of the questions that was asked too in terms of the training set size. So for this sort of approach to work, is it always the case that you need a fairly large training set? You mentioned in your example 22, I think 100 plus students to be able to get to accuracy. So is it always going to be a size issue?
So I think there is this issue that I think we have to just understand that maybe it is not about the size, it is all about how diverse the responses are. If we have a smaller data set, which is still diverse enough, so the system should be able to pick up those diverse responses and it should work out. So it is not about the size. If we have, let's say, 3,000 students, but most of them are gifted, high ability students, so they are writing very accurately. So in that case, it's still not good enough because obviously it's not going to help us create a representative or a diverse scoring engine that can understand poor responses, like a moderate responses, and still high quality responses at the end. So that I would say, again, the diversity of the responses is the main thing rather than the size of the data set that we are using for training.
Right. So the results, folks are still seeing challenges, which I think you were honest about, and there's still a lot of work to be done. But I think the overall perspective here is that these sorts of things will eventually take hold, and as you mentioned, be an opportunity to improve the processes that we already have instead of replacing them and replacing folks. Somebody mentioned the Terminator. Also, it seems a lot of times these kinds of conversations quickly go to kind of pop culture views on this sort of thing. And what I heard in your talk is let's rein it back to what computers are really good at and keep honing in and making those improvements.
Exactly. So I think instead of replacing human raters, so the ideal scenario, and which I believe some testing companies are already doing that, is that they they are running some human raters along with computers, so 2 raters. If there's still some kind of misalignment between the marks, so they bring a third human rater in that case to solve that issue, that misalignment in the scores. And I think that's quite great, because at the end of the day, instead of hiring 2 raters, spending all the time, you have only 1 rater, and the other rater is kind of the machine or computer running it in the background quite efficiently.
Yep. Lots of opportunities for teaming.
Definitely.
I really appreciate your presentation. And with that, we're going to get started on our final session for the day.